So we're going to talk about radioactivity today. So now we're talking about nuclear phenomena. Now what is radioactivity? Well, radioactivity is spontaneous emission of high energy particles. By high energy, what I mean here is hundreds of kilo electron volts, or maybe even an MeV particle, right, coming out of nucleus spontaneously. And this happens because once nucleus become very, very heavy, like for instance the americium nucleus or strontium or cobalt, cobalt has got 60 nucleons in there, and the nuclear levels, there may be some of those isotopes, if you like. If you have different number of protons and neutrons, they may actually have unstable situations where they want to release some energy. So when they release energy, the particles which come out have high enough energy that they can actually trigger the electronic circuits here, and it can make and we have connected it to a speaker here. So the speaker isn't behind there, and it's going to chirp whenever particles come. So here are some particles coming and striking the Geiger counter. I can hear the chirping. Farther you take out, there's less of them because they're spreading, right? If I touch it, it goes really high. So here's the different kinds of particles, beta particles, which are coming. This is a more active source, a lot of beta particles coming out of it. Here's another source which is called alpha source. How do I know that this is alpha, this is beta, this is gamma? Why did nuclear radiation get classified in three different ways? Well, we'll talk about that in a minute. But radioactivity is everywhere. So a lot of people are scared about radioactivity. Well, because the energy of these particles is high, they can actually modify the chemical properties. And if they modify chemical properties of chemicals inside biological systems, yeah, it can produce cancer. And there's radioactivity everywhere. So here, for instance, is an orange plate. Nothing is happening. Here's another thing. It's also orange, looks very similar. You know, this orange paint is radioactive, right? I'm touching it. It's not that big a deal because this is low levels of radiation. So let's get back to why these are classified in different ways. So here are particles coming through, and let's see if we can stop them. These are alpha particles. I put a piece of paper. Let me touch it actually, right? You can hear the chirping. I'll put paper. The chirping has reduced quite a bit. You can use plastic. It pretty much stops it, right? There's a little bit of chirping, but not very much. But if I put an aluminum plate here, it stops it too, right? Whereas if it's not that we turned off the thing, it's just chirping very high without anything. So these alpha particles, you can stop even with paper or plastic. Let's look at beta. Well, with paper, we are not able to stop it as much. Let's try plastic. Not really so much. Let's try aluminum. That has reduced quite a bit. If I have one single sheet of lead, it pretty much blocks all the beta particles. Now let's look at what happens with the the gamma particles. I have my paper, no change, right? You know, without, with paper, with plastic, with aluminum, with even lead. Even lead cannot stop this high energy photons coming through. These are like X-rays, right? So these are even higher energy than X-rays. So they can penetrate huge amounts of material, and as a result, you know, with this high energy photons, you can do all sorts of interesting tomography, as you would call it. So you can look at insides of material, and very heavy elements seem to be able to have some effect. So radioactivity has very interesting applications. They may be dangerous for biological systems, but they could also be very useful by using them for imaging, if you like. So there are lots of instrumentations which are built on based on radioactive principles, which you will learn about in lectures in a little bit more detail from Cecile.